Hello guys, welcome back to Maison African Motives. In this platform, we shall be focusing on differentiation, that is for mathematics and for. So I just want to focus on the revisions that we have, how to differentiate typical exam questions, which is one of the most important platform that you're supposed to have before your final examination. So on 4.1, not wasting much time, from the question paper of November 2016, we are given to differentiate the following in terms of x. So that's an expression for y that we are given. So always when you are differentiating, try by all means to rewrite in a format that you can actually be able to differentiate. So I'm just going to rewrite our expression, then we can have the best format for us to differentiate this. So we're given that y is equivalent to 3 pi to the exponent of x. This is what we are given, plus a third of log x in base of 3. So this is x in base of 3 minus 1 over 3, the tan of x. Okay, so we've got tan of x minus the square root of x plus 3 over sine of x. Okay, so this is what you're given in this case. So the first part, we are just rewriting in a format that we can differentiate. So we are not differentiating yet. The first part, there's nothing because we know this format, we are able to differentiate this. So we are not going to do anything here. So we are just going to rewrite as it is. So it's 3 pi to the exponent of x as it is. The same thing with the log. We can differentiate a log, guys, if you remember this. So you just have to rewrite as it is again. All right, then here we've got 1 over 3, then it's tan x. So remember, guys, from our identities, 1 over tan, it gives us cot. So this is going to be minus 1 over 3, but 1 over tan, it's cot. So this is going to be cot of x. All right, from our exponents, we know that the square root is same as to the exponent of a half. So from your mathematics N3, I still hope you still remember this concept. So this is to the exponent of a half plus, then we've got 3 over sine of x. So remember, 1 over sine is the same as cosec. So this is going to give us 3 cosec of x. 3 times cosec is 3 cosec x. All right, so we have written this in a format that we can actually be able to differentiate each. So let's start with the first one. How are we going to differentiate these guys? Which part are we going to apply here? So this is now dy dx. The derivative of y with respect to x, we've got pi to the exponent of x. So take note here that let me just rewrite this because we are given actually this derivative from our formula sheet. Let me just show here, we're given that if it is k a to the exponent of x, that's k a to the exponent of x as it is, then it's ln of a, whereby a is the base that is a in this case. All right, so that means in this case, we are going to have our k being the constant, which is 3. So this is going to be 3. Then we've got pi to the exponent of x as it is, but we are going to have a ln affecting our a. Our a in this case, it's pi. So this is going to be ln pi like that. Okay, then we've got the derivative of a log. In this case, if you are to check in your formula sheet, we do not have the derivative that has got a direct log like this. Okay, so let me explain the derivative of a log. What are we supposed to do if we are given a log? Okay, so if we are given the derivative with respect to x of a log, let's just write it this as a log f of x is going to be a function of x in base of a. So I'm just treating the whole function like this one. It's a function of x. So the derivative of a log is equivalent to the first derivative of f of x that we are given, everything over the ln of a times f of x, which is the normal x that you're given. So in this case, if we are to apply this concept, you're going to see that this is going to be a third is just a constant. This a third here is just a constant. So you're going to have a third multiplied to the first derivative of f of x, of which our f of x is x. So the first derivative of x is 1. So this is going to give us 1 over ln a, which is A is the base. So our base in this case is 3. This is our base. So it's ln 3 times f of x. Our f of x in this case is x. So this is going to give us x like this. Okay, so if you are to combine everything in this case, let's say you've managed to combine, it is going to be plus 1 times 1 here, which is 1 over. This is 3 times ln 3 times x, which can be written as 3x ln of 3, like that. Okay, so this is what you're going to have as our final answer from this part that we had. Okay, let's see the other part. We've got the derivative of cot, which we are given from our formula sheet. We are given cot, it's negative cosec squared. So this is cosec squared. So that means we are going to have a negative cosec squared, but already we are having a negative here. So a negative versus a negative, it's a plus. So it is going to be 1 over 3, which is a constant, but cot gives us cosec squared. So it's going to be cosec squared x. All right, we've got x to the exponent of a half. Remember the concept, guys. If you are dealing with this, you have to drop the exponent here, which is going to be half. So it's going to be negative half here. X to the exponent, we subtract 1 from the exponent. So it's half minus 1, which is a minus half. So we can rewrite this from our laws of exponent. Remember, to the exponent of a negative, it's 1 over. So it's going to be negative 1 over 2 x to the exponent of a half, of which you know that to the exponent of half, just like what we did previously, it was the square root of x, then we wrote it as x to the exponent of a half. So if we are given x to the exponent of a half like this, it means the same thing as the square root of x. So that means from this part, we are going to obtain negative 1 over 2 the square root of x. So that's what you're going to have from this part here. All right, then we've got cosec x. Okay, this one, lucky enough, we are given this in our formula sheet. The derivative of cosec x is negative cosec x cot x. So we are going to have a negative in this one. So it's going to be negative 3, which is a constant. Then it's going to be cosec cot. So this is going to be cosec of x cot of x. All right, so that was the derivative of the whole expression that we're given in this case. So this typical question, they will be marking each part. So you have to make sure that each and every part is well shown, and try by all means to apply the derivatives that you're given. Sometimes you're not given these, you are supposed to know these derivatives. So I encourage you to revise as much questions so that you do not have a challenge when dealing with these derivatives. Okay, on 4.2 is still on derivatives. The whole of the question is on derivatives. So on 4.2, we are now given that y is equivalent to the square root of x into x squared plus 1. Differentiate by use of the product rule. So take note, we are given what to use in this case, the product rule. Okay, so that was question 4.2. Just going to write it here. So on question 4.2, we are given that our y in this case is the square root of x. Okay, so that is 4.2 here. So but take note, guys, square root of x, I explained it here. We said it's the same as x to the exponent of a half. So this is same as x to the exponent of a half into x squared plus x plus 1. So remember that from your product rule, you are supposed to have two functions, the function of u and the function which is vx in this case. And we know that the derivative of y with respect to x is given by the formula. It's going to be ux by the first derivative of vx plus the first derivative of ux by vx. So take note, it's ux, the first derivative of vx. On the second part is the first derivative, of which you are given this in your formula sheet. So there's no need for you to worry much. You can have this formula you are given here. So that is your product rule. It means the two functions, they are multiplying each other, just like what we can see here. These two functions, they are multiplying each other in this case. Okay, so that means our ux is x to the exponent of a half. That's what we have. And our vx is this part. So you can find the first derivative, you can calculate them separately, or you can just calculate this direct here. So that means our dy dx is going to be ux. That means just rewrite ux as it is. Remember, our ux is x to the exponent of a half, which was the same thing as the square root of x. Remember, this was square root of x. So we can even write this as the square root of x. Okay, then vx, the first derivative of vx, that means we are finding the derivative of v, that's x squared, which is going to give us 2x plus x here, which is a 1. The first derivative of a constant, that's a 0. So that's what you're going to have here, plus the first derivative of ux, of which our u is x to the exponent of a half. So how can we differentiate x to the exponent of a half? We saw that part. We did this derivative. You drop the exponent, which is going to give us half. X to the exponent, we subtract 1 here, which is going to give us a negative half. And remember what we did from the previous question. I told you a negative is same as 1 over, so it's going to be 1 over 2 x to the exponent of a half, which is same as 2 square root of 2. So it's same as 2 square root of x, sorry. So this is going to be in that format. So it's going to be 1 over. So, okay, let's just have it this way. So we are going to have it as 1 over 2, the square root of x. Okay, so that's what you are having on the first derivative. Whatever that you have, you multiply to vx. So vx in this case is this whole bracket. So you just have to multiply to x squared plus x plus 1 like this. Okay, so that's what you have, or you can even write it at this. You can even leave it at this stage. From this stage, you can just leave it at this stage, or you can write it like this. It's one and the same thing from this part. So there's no need for you to expand these brackets. Just leave your answer like this. You've got the full marks for this question. Okay, so that was question 4.2. On 4.3, we are now given that the derivative, okay, we are given the value for y, the expression, then solve the second derivative of y with respect to x when it is equal to a 0, and that is 4 marks. Okay, so that was question 4.3. Let's have our question down so that we can try to work this one out. So this is question 4.3, where we are given that y is equivalent to 3x to the exponent of 3 plus 9x squared plus 3. And we are asked to solve if the second derivative is equivalent to a 0 in this case. So what is the meaning of this, guys? It's an equation that you're going to formulate from the second derivative. So for you to have the second derivative, first you must have the first derivative, which is dy dx. Okay, so 3 times 3, that's 9. So it's going to be 9x. You subtract 1 here, which is going to be 2. And yes, 2 times 9, which is 18. So this is going to be 18x. 3 is a constant, so there's nothing that you're going to have here. Okay, so that's our first derivative. We move on to the second derivative. Remember, it's the second derivative with respect to x, which is 2 times 9, that's 18x. We subtract 1. Then this is 18x, which is just 18. All right, so we're given that this second derivative from this formula, it must be equal to 0. So that means we are going to equate what we obtained from the second derivative. 18x plus 18 is equivalent to 0. So 18x is equivalent to negative 18. We can divide by 18 both sides. So that means our x is going to be equivalent to negative 1. So therefore, our x is equivalent to negative 1. So that was the question, guys. Find the second derivative equal to 0. That was it. So these are some of the typical questions, and they will be very, very easy questions that you need to understand the concept from this one. Okay, 4.4, we are given the derivative to determine by the use of differentiation the coordinates of the maximum and minimum turning points of the given function. Okay, so that's a function that you're given where we are given that in this case, y is equivalent to 2x to the exponent of 3 minus 8x. Okay, so that's question 4.4. So remember that at any turning point that you are having, the first derivative of y with respect to x must be equal to 0. Okay, so that's the concept. So that means for us to have these points, we are supposed to find the derivative of y with respect to x. And our dy, the x in this case, this is going to multiply 2 times 3, which is 6. You subtract 1 here, which is 6x squared. Here we're going to just take as minus 8. Okay, so this is what we are having from the first derivative, but we are saying at any turning point, this must be equal to a 0. So you're going to equate 6x squared minus 8 to a 0. So you can solve for x in this case. What are the values of x that you're going to have? So 6x squared, we can transpose 8 minus 8 to the other side, which is going to be positive 8, divide by 6 both sides, so that we can have the values of x. So we've got 8 over 6. Then to find x, as you can see, this is squared. So you have to introduce the square root both sides. So x, remember that square root of any number is a plus or minus. Okay, so let me just share the whole of the screen so that we can see the calculator here. So from our calculator, we have got the square root of, so this is the square root of a fraction, that's 8 over 6. Okay, I need the square root first. The square root of a fraction, we've got 8 over 6 like this, which is going to be 2 square root of 3 over 3. So you're going to have 2 square root of 3 over 3. Okay, so this is the value of x that we are having. These are the values of x actually that we are having. So the turning points that you're going to have are going to be, okay, let me indicate them separately. So x is 2 square root of 3 over 3, or another x is equivalent to minus 2 square root of 3 over 3. So for you to find the values of y, you're going to substitute the value of x, which is 2 square root of 3, in place of x in the original equation here. So in place of x, you substitute that value. Okay, so that's how you're going to obtain these turning points. Okay, so we've got the first turning point, which is at a point where x is 2 square root of 3 over 3. So if you substitute this properly in the calculator, we are going to obtain something of this nature here, which is negative 6,158, something like that. Okay. Or the second turning point that we have, which is at a point where x is negative 2 square root of 3 over 3 like this, it is going to be something like 6,158. Okay, if you use your calculator properly there. So these are the two turning points that you're given. So for you now to tell the point, is it a maximum or a minimum turning point? This is the idea that you're supposed to do. You work with the second derivative. From the second derivative, if the answer is greater than 0 like that, that means that's a minimum turning point, okay? If you find the second derivative with respect to x, if the answer is less than 0, that means that one is a maximum turning point. Okay, so this is what you're going to do from the first derivative that we had. Remember, we've got dy dx here. This was our dy dx, which is 6x squared minus 8. So you're going to find the second derivative from there. Okay, so that is the concept, guys. Remember that our dy dx was equivalent to 6x squared minus 8. So the second derivative with respect to x, that's 6 times 2, which is 12x. Then minus 8 is a constant, so there's nothing that you're going to obtain from this one, okay, because we've got a constant there. So this is the second derivative that we are having. But I'm saying from this second derivative, if you are to check, it's written in terms of x, all right? So that means if we are to take the first turning point that we had, the value of x that we are given on the first turning point we are given here, this is our first turning point that we have, where x is 2 square root of 3 over 3. So if you are to substitute this value here in place of x, it is going to be like this. It is going to be 12 multiplied by 2 square root of 3 over 3. By just looking at the number, even without getting the values for this the part that we are having, it's a positive. And it means the second derivative with respect to x is actually greater than 0. Greater than 0, that's a positive, because you're having a positive, as you're going to obtain a positive answer here. So if it is this way, that the second derivative is greater than 0, that means this turning point is a minimum turning point. So therefore, this first turning point that we have here is a minimum turning point. You move on to the second turning point, our x is minus 2 square root of 3 over 3. So if you are to substitute here in the second derivative, it is going to be like this: 12 multiplied by negative 2 square root of 3 over 3, of which here we are going to obtain a negative answer. That means our second derivative with respect to x, it's less than 0 because it's a negative. And if it is a negative like this, that means it's a maximum turning point that we are having. So here we are going to conclude that the second turning point that we have in this case here is a maximum turning point, we saw that the second derivative with respect to x was actually less than a 0. So that is to prove that it's a maximum turning point. So this is how you actually solve these typical equations on derivatives, especially on determining the turning points, whether it's maximum or minimum. You work with the first derivative with respect to x. It must be equal to 0. For you now to tell or to differentiate, is this maximum or minimum? That's when now you work with the second derivative. So these two here are very, very important because this is the comparison that you're going to take when dealing with the minimum or the maximum turning point. Okay, so that was actually question 4.4 from the derivatives of this question paper. As you can see, guys, that was a total of 20 marks on everything on differentiation. So you need to revise as much questions as you can as you are preparing yourselves for the exams. And also, don't forget, if you are new, you can actually subscribe so that you become part of the family. Maison African Motives. And don't forget to share our videos, our platforms to your friends so that they also can benefit from this information that we are having, and also to join the membership platform. If you join that membership platform, that means you've got access to different question papers and also the questions of your choice that you're having by just joining. So that is the one of the most important part that you need as you are preparing for this exam. So that's it, guys, for Maison African Motives. Till we meet again.